Hello, pre-calc, and welcome to Chapter 5. All right, this chapter is analytical trigonometry. So there's a lot of stuff in here. There's your trig that we talked about, and then we're going to do a little bit of proofs, our rearranging of formulas and how to work with those, find exact values of things. Now, on the back of this chapter, you have this sheet right here. Okay, I'm hoping you can kind of see it. All right, that sheet is something you get to use on your quizzes and your test. So you can use the sheet. You can't put anything else on it, all right? But it does give you all your formulas and what you need to know. So it's got your formulas that we'll be using all the way through. I highly suggest you tear that off. You use it when you're doing your homework and your other things so you know everything is at. So let's get moving. Our first section is verifying trig identities. And these are like little bitty puzzles. They're really quite fun. All right, so we want to verify trig identities. Now, if you notice, these formulas are on that sheet you have. All right, so we got basic trig identities, and this is what we're going to use to solve things. So we know, some of these you've already know, that tan is sine over cosine. There you go. You know this. You know that the cotan is a cosine over sine. You know the reciprocal, so if your sine is 1 over cosecant, cosine is 1 over secant, 1 over tan, and the same with the others. Pythagorean identities, these we are going to use a lot. So cosine squared plus sine squared equals 1 is the one that you need to know. All of these come from this Pythagorean identity. So if I divide everybody by the cosine squared, this would become 1, this would become tangent, and this would become secant squared. If I divide everybody by the sine squared, this becomes cotangent, this becomes 1, and this becomes cosecant. That's where these two are derived from. All right, we are going to do cofunction identities. Oops, that's just where you subtract. Here we go. An angle. So I'm taking 90, or pi over 2, minus an angle. That gives you the cosine as is. So the sine is just shifted 90 degrees. And the cosine is shifted 90 degrees to get to the sine. The tangent shifted 90 degrees. It gives you cotangent. Negative angle identities. So the sine of a negative angle is equal to the negative side, which makes sense because remember that's the y. So the negative goes down and the positive goes up. So the sine is like when you're on your x and y. When your sine is up, your sine is positive. When you go down for your negative, then your sine is negative. Cosine, well, that goes off the x. Well, you know if you go x up, that's positive, but x still down is still positive. So the cosine of an angle is just itself. Tangent, of course, is sine divided by cosine, so it is negative. The same is true with your cosecant, secant, and your cotan. All right, we are going to simplify expressions. So we want to prove to me that this side equals this side. So you don't get to, so you don't get to touch the secant. So when we look at this, we just write in what we know. This one's a fairly one just to get you started. We know cosecant is 1 over sine theta. We know tan is sine theta over cosine theta. Well, when we multiply those together, the sines cancel, giving us 1 over cosine. But we do know that cosine is the secant theta. So we are done. We've proved that identity. All right. Now I want you to pause and try yours. You're going to prove the secant of theta times the cotangent of theta is equal to the cosecant of theta. All right, you should have, there's lots of ways to do these, by the way, all of them throughout. So if you do it different than me, but you get to the same answer, that is probably just fine. So we know that the secant is 1 over the cosine of theta. We know the cotangent of theta is the cosine of theta over the sine of theta. All right, our cosines cancel. This equals 1 over the sine of theta, which is the cosecant of theta. We have proved our identity. Okay, the next one we have is the cosine of pi over 2 minus theta times the cosecant of theta. I would like to know what that equals. Well, this is one of our identities. If we shift the cosine 90 degrees, we get the sine. So cosine of pi over 2 minus theta is equal to the sine of theta. We know cosecant of theta is 1 over sine. So when we cancel these out, our answer is 1. All right, pause and try yours. You should have realized that the cosine of negative theta is the same as the cosine of theta. All right, the sine of negative theta is negative sine of theta. Remember, the y value goes down. Cosine divided by sine is cotangent, but this time it is negative, so you should have got the negative cotangent of theta. See, aren't these kind of fun little puzzles? Just see where you can get. All right, I would like to prove that this side right here equals this side. Usually when you're doing a proof, you can only work one side of the equation. It doesn't matter which one. You are new at this, so if you get stuck, I will let you touch on both sides, but we would prefer if you stayed with one. So when I look at cosine minus cosine theta sine squared theta, I have to figure out what to do with that. Well, I know they both have a cosine in common, so I'm going to factor that out. So I got the cosine of theta is equal to 1 minus sine squared of theta. Well, by our identity above or on your paper, we know that 1 minus sine squared theta, that's actually equal to the cosine squared. Remember, you have, whoops, I should probably write it exactly as it is on your paper. We have the sine squared of theta plus the cosine squared of theta equals 1. It's our Pythagorean identity. So if we subtract the sine squared from both sides, we have the cosine squared of theta equals 1 minus the sine squared of theta. We can rearrange those identities any way that we need. Well, therefore, the cosine 1 minus the sine squared is equal to the cosine squared of theta. So now I have the cosine of theta times the cosine squared of theta. Well, that's simply the cosine cubed of theta. This delegates what you're doing. So if I have all cosine here, I know I need to get this side to all cosine. So I've got the cosine out here, which means I need to find a way to get the sine squared into cosine. That's what you're looking for. I hope that helps you. All right. Shoot, I should have paused and let you do yours. Okay, pause and do yours. Make sure you read your hint. All right, your first thing you should have done, break this up. So that's 1 over the cosine of theta. Remember, we're just rewriting this. And that's the sine of theta over the cosine of theta. Well, we know 1 over cosine is the secant of theta, plus sine over cosine is the tan of theta. Voila, check. We have proven our identity. See, they're not so bad. These are a lot more fun. All right, I have the sine of x, 1 plus cosine of x, and I want to prove that that's equal to 1 minus cosine x over sine of x. Oh, this looks fun, doesn't it? How am I going to get to the sine of x in the denominator? Looks a little difficult, right? So this is where I want to go. This is what I have. Okay, well, I know that I need a sign in the denominator. I know that 1 minus sine squared is cosine squared. I'm pretty sure I can get this here by using the conjugate. So I'm going to multiply both by 1 minus cosine, top and bottom. Everybody good? So when I do this, I leave the numerator alone, while this is just 1 minus the cosine squared. Awesome, because we know that 1 minus the cosine squared is the sine squared. Well, not quite there because I need sine up here. But I have a sine in the numerator and 2 in the denominator, so I can cancel those. Oh, this should have been an x here. I am sorry, I wrote that wrong. Now, I've got 1 minus the cosine of x over sine of x. Not bad, right? Okay, pause and try yours. A little bit harder, but not much. Okay, this is where you were going, so I need to get to secant. This denominator is just a mess, right? So let's at least try to put it together. See if that gets us anywhere. It may or may not work. So this guy needs a cosine of x. This one needs 1 plus the sine of x to get a common denominator. And we'll do that on the top too. And the cosine of x up here. All right, when we do that, we are going to get the cosine squared of x on the numerator. Let's see if we got that. I can write this out. Cosine squared of x plus Now, if I multiply these two, you're just squaring this, right? So you square the 1. You're going to get 2 of the middle term, 2 sine of x, plus the last term squared, sine squared of x. Ooh, that's pretty interesting, huh? All over the cosine of x times 1 plus the sine of x. Well, we know that the cosine squared plus the sine squared is equal to 1. So we can combine those two. And we're going to have 1 plus 1, because cosine squared plus sine squared is this one from right here, plus 2 sine x all over cosine x times 1 plus sine x. Doesn't look like we're getting far, does it? Let's keep going. So then we got 2 plus 2 sine x all over cosine x times 1 plus the sine of x. Well, that numerator can factor out that 2. That gives me 1 plus the sine of x. Oh, isn't that pretty? All over the cosine of x times 1 plus the sine of x. Well, those can cancel since they're the same. And we know that 1 over cosine is secant, so we really have 2 secant of x. Wasn't that slick? Look how smart you are. Okay, let's try the next one. Oh, that one looks really hard, doesn't it? All right, let's not freak out though. Remember, this is where we want to get. So sine and cosine. So everything's got to be in sine and cosine. So let's flip some of these things around. I know that secant is 1 over cosine. Okay, cosecant of a negative x is the same as minus cosecant of x, because that follows the cosine rule, right? Secant is 1 over cosine. Cosecant is 1 over sine. All right, I still got to get this cosecant out of here. So I'm going to change him to 1 over sine. All right, we've got everybody to sine cosine, but now they're on the denominator. So we got to get a common denominator. Well, this guy's multiplied, so my common denominator is cosine sine. So that means this top one here needs a sine of x. This one over here is going to need a cosine of x. All right, my denominators are all the same. So I can cancel these guys. I can cancel these guys, and I'm left with, I showed this step, sine of x, good, because these guys are gone, right? Minus the cosine of x. Oh, look up there, that's exactly what we wanted. We are so lucky. All right, pause and truly try this. Do not mess things up. Common denominator, then we got to get the cotangent, because before we can do this, we have to do that. That's your hint. So pause. Remember, this is where you're headed. So you should say common denominator is 1 minus cosine times 1 plus cosine. This guy needed the 1 plus cosine and 1 plus cosine. All right, so my denominator, when we actually multiply that out, is 1 minus cosine squared of x, right? My numerator now is 1 minus cosine of x plus 1 plus cosine of x. So what do we got here? So when I look, the 1's double, so that's a 2, and the cosines cancel. Don't know if that's good or bad. I know that 1 minus cosine squared is sine squared, right? Okay. Okay, so 1 over sine squared is the same as sine squared is 2 times the cosecant squared of x. All right, does that help me? What do I know about cosecant? I know cosecant from my table is 1 plus the cotangent squared of x. Distribute that 2, and we are there. Wasn't that slick? All right, now, there are like 100 ways to do this proof. I showed you one. I'm not going to show you them all. If you had a different way, that is perfectly fine. All right, make sure you're doing your homework, post questions on the discussion board, and don't forget your quizzes. Have a great day. Bye, everybody.